Hello, welcome to the second installment of Hotard's Algebra 2 lesson, home of all things related to, you guessed it, Algebra 2. Today is April 57th, I think, and our lesson today, still dealing with logarithms. We're going to be dealing with properties of logarithms, specifically expanding and condensing logarithms. I know you're excited, so we're going to get started. Okay, here are your notes faithfully posted on Moodle. Today we will be using properties of logarithms, like I said, to expand and condense logarithmic expressions. Now before we get into how to do all this stuff, really quick I want to talk about the why. I know I'm going to give you a lot of information today. We did some yesterday and later on this week. Everything that I'm teaching you this week in isolation, these skills you would never use in your life, all right? But when we get later on next week into actually solving equations dealing with logarithms and exponential equations, that has lots of real life applications, and you'll be using everything I teach you this week in order to do that. So it is important to actually understand this material this week so that you know what's going on next week. Just remember, everybody said, oh, exponential growth, I'll never use that in my life. Everybody said that, and then coronavirus hit, and here we are. So anyways, that being said, let's get started. Properties of logarithms. Now we're going to start today with something that you should already know, laws of exponents. All right, remember when you're multiplying two things, when you have the same base, different exponents, when you're multiplying, you remember what you did with the exponents? You add them. A to the m times a to the n, that's a to the m plus n. And when you're dividing, a to the m divided by a to the n, you subtract the exponents. A to the m minus n. And then this last one, power to power, something raised to an exponent and then raised to another exponent. You remember what you did with those exponents? You multiplied them. A to the m times n. All right, now you're thinking, what does this have to do with logarithms? Well, I'll tell you. You recall in the last lesson, I told you, important, logarithms always equal exponents. They follow all the same rules that exponents follow. So I can use these same laws of exponents that we already know and love. I can use them to rewrite logarithmic expressions. So if you look over here, when I have log base whatever of something times something else, going by that same logic, when I multiplication with two exponents, I could turn it into what kind of problem? Addition. So same thing here. Log base b of m times n. I can rewrite this as log base b of m plus log base b of n. Now you notice I didn't write it as log base b of m plus n. It's two separate logs. Log base b of m plus log base b of n. Now, same thing, the same thing is true for a division problem. All right, division, if I'm dividing, I can subtract the exponents. So with logarithms, if I have log of something divided by something, I can turn that into a subtraction problem. That's log base b of m minus log base b of n. All right, and then last property here, power to power. When I have an exponent raised to an exponent, I can multiply the exponent. So the same thing is true here. Log base b of m, remember a log is an exponent. So if you have an exponent raised to another exponent, you wind up multiplying them together. What that means is I can take this exponent, this n, and I can move it to the front. And I can write this as that exponent n times the log of that whole thing. This is n times log base b of m. All right, so these three things, if you can remember these three properties of exponents / logarithms, you'll be able to do every problem I give you today. So two things we're going to be doing with those. First, we're going to be expanding these logarithmic expressions. What that means is that I'm giving you one log, you're just going to rewrite it as more than one log. The problem has one log in it, your answer should have more than one. So if you look at problem number 1, log base 2 of 4x. This is 4 times x. It's multiplication. This is multiplication. That means I can rewrite it as a what kind of problem? Addition. So I can rewrite this problem as log base 2 of 4 plus log base 2 of x. And that's it. That's all we're doing. We're not solving anything today. We're just rewriting it. We're expanding these. All right, so problem number 2. I can do the same thing here. Now, you notice problem number 2, how many logs do you think they're going to be in the problem? In my answer, rather. It's going to be 3 of them. One for the 8, one for the x, and one for the 3. So first of all, I have 8 times x, multiplication, so I can turn that into addition just like I did the last problem. So I could write this as log base 6 of 8 plus log base 6 of x. Now I'm not done. This whole thing is being divided by 3. All right, remember division, you could turn that into what kind of problem? Subtraction. So I'm also going to have minus log base 6 of 3. This is my answer for number 2. Oh, make sure you can actually see it. Log base 6 of 8 plus log base 6 of x minus log base 6 of 3. 3 logs in that answer. Now problem number 3. Just draw an arrow so I can actually see what I'm doing. Log base 7 of 3y to the 8th. Again, 3 times y. This is multiplication. So I'm going to turn this into addition. I'm going to rewrite this as log base 7 of 3 plus log base 7 of y to the 8th. Now, we're not done though, because you recall we had a power-to-power property right here. When you have an exponent inside of a log of something to some power, you notice you can move that exponent to where? To the front of that specific log. So I can take this 8 exponent and I can move it, based on that property, I can move it in front of this log. Not in front of the whole problem, in front of that last log. So my answer, I would say log base 7 of 3 plus 8 log base 7 of y. That's my answer for number 3. And then number 4, log base 7 of 3y to the 8. Well, isn't that the same problem we just did? No, not quite. What's different about it? The parentheses. All right, in number 3, the 8 exponent only applied to the y, not to the 3. But here in number 4, this 8 exponent applies to both of them, to the 3 and the y. So my answer is going to be almost exactly the same thing I had in number 3, except what's going to happen to that 8? It's going to be on both the logs. I'm going to have it here on this log. I'm also going to have it here on this log because it also applies to the 3. So my answer for number 4, I would say 8 log base 7 of 3 plus 8 log base 7 of y. That would be my final answer, expanding that. 8 log base 7 to 3 plus 8 log base 7 to y. So remember, main things to remember here so far, when you have multiplication, turn it into addition. When you have division, turn it into subtraction. When you have power to power, exponent to an exponent, all right, you can move that exponent to the front. If you can remember those 3 things, you could solve every problem. Now, that's expanding. This would be a really good point now to pause the video, open up the textbook problems that I posted on Moodle, try a few of the problems at the beginning on expanding, check the answer key, make sure you can do those correctly. Once you got that down, come back, finish the video. All right, I'm going to assume you did it. Of course you all did. You always do what I ask you to do. So now, second half of the video, we're going to look at condensing. This time, I'm giving you more than one log. We're going in reverse. Your final answer is only going to have one log in it. So problem number 5, log base 3 of 9 minus log base 3 of x. This is a subtraction problem. So I can change, according to my properties, I can change a subtraction of logs problem into a what kind of problem? Division. So I would rewrite this as log base 3 of 9 divided by x. It's divided because it's subtraction. If it had been an addition right there, then I'd say log base 3 of 9 times x. And that's my answer. Now, yes, you could put it in parentheses. It's not wrong if you don't put the parentheses, either way. So number 6, I'm going to do the same thing. Now number 6, you notice there's numbers in front of these logs. All right, that property, that power to power property, if you have something in front of the log, that means that number was a what? An exponent. So I'm going to use that here. Number 6, this 6, I can move it up here, make this m to the 6th. And the same thing with the 2. Move it up here, make that n to the 2nd. So this is like saying log base 5 of m to the 6th, let me just write that, log base 5 of m to the 6th minus log base 5 of n to the 2nd. Now we're not done because remember our final answer when we're condensing should have how many logs? 1. We've got 2. So this is subtraction. We need to turn it into division. So my final answer, I would say log base 5 of m to the 6th divided by n to the 2nd. All right, again, you could put that in parentheses if you want. It's not really wrong if you don't, but there it is. All right, 2 more problems. We are almost done. Looking at number 7, ln. What does that mean? All right, remember ln, that's natural log. That's just log base e. As far as what does it mean for you in this problem, it means you do it the same way you did every problem that said log. All right, so I'm going to start right here. Now, I've got a number in front of this log. That means that's an exponent. I can move it up here. This is really 2 to the 3rd. All right, and then I have an addition right here. So this is like ln of 9 plus means I turned that into multiplication. So 9 times 2 to the 3rd. And then subtraction, I can change a subtraction problem into what? Division. So divided by 3. There it is. All right, yes, you could work that out if you want. Really, I'm just looking to make sure that you can use the properties of log. So you can just leave it in that form. All right, and then one last problem. Last one. All right. This one, again, I'm seeing numbers in front of the log. That means these numbers are going to become what? Exponents. So I'm just going to move this 1/3. This is going to become x to the 1/3. Same thing here. That's going to be y to the 1/3. So I'm going to have log of x to the 1/3 plus log of y to the 1/3. Now I'm seeing addition. That means I can turn it into what? Multiplication. So I would write this as log of x to the 1/3 times y to the 1/3. Now, this is correct. If you gave me this on a test, there are no tests this year, but if you had given me this on a test, I would give you credit for that. But if this were a multiple choice question, that's not what the answer choice would be, because you recall this 1/3 exponent, all right, there's another way of writing the fraction exponents. That's the root. Remember, the bottom number of the fraction exponent tells you what kind of root it is. So this is like saying log of cube root of x times y. All right, one more time, because I know that's a little tricky for some people. It's been a while since we did that. But anything to a fraction exponent, that bottom number of the exponent, that is the index. That is the root number. So x to the 1/3, that's like saying cube root of x to the 1 power, but you don't have to write the 1. Same thing with the y. Cube root of y to the 1 power. Since they're both under the cube root, we just put it together like this. And one last thing, you notice, unlike every other problem on the page, this problem did not give us a base. It just said log. All right, that's not a mistake. You remember what the base is when there's no base written? It's 10. So that's just saying log base 10, but you're doing all the same things. So that is my final answer. All right, so again, if you have any questions about anything on here or any of the problems in the assignment, feel free to email me. I'm checking my email every day between 10 and noon. You'll get an immediate answer if you email me then. If you email me later, I'll get back to you as soon as I can. All right, y'all be safe, be good, and I will see you later. Bye-bye.